Hello students, welcome to IMS Academy. In today's session, I would like to do GATE questions selected from GATE 2022. I selected those questions from ECE and electrical branch. Those problems you can practice more. The way how I will do these questions, so please watch it now. I'll start the questions one by one. This is the question from the analog ECE branch only now. GATE 2022 I said. Consider the circuit shown with an ideal long channel N MOSFET. Enhancement mode. Substrate is connected to the source. The transistor is approximately biased in the saturation region with VGG and VDD such that it acts as a linear amplifier. VA is the small signal AC input voltage, VA, VB represent the small signal voltages at the nodes A and B respectively. Is asking to find the value of VA by VB. How much? Rounded after 1 decimal place. But what is given in the problem? Initially you must understand what is given in the problem and what he is asking. That is also very important. The problem is given directly, you should not do. First you have to read that problem. Because the VA by VB is under DC analysis or under AC analysis, we need to calculate. That you must understand at first. Here what is given in the problem? The sources are given VGG and VDD. Two sources are given here now, VGG and VDD. What purpose those two are connected? For approximately bias, for the sake of the biasing, For the sake of proper biasing, it is connected VGG and VDD. These are the two DC sources. And also what is asking, VA and VB represents small signal voltages. Not small signal voltages indicates what? Under AC analysis only, we need to find VA value and VB value. Then we can find the ratio of VA by VB only now. Under DC analysis, it is not required, directly specified in the problem. Small signal voltages given directly. But if you want to apply small signal analysis, what those conditions you must know very perfectly. That is very important. Here the DC and AC sources you got. Under AC analysis means wherever DC source is given, that is nothing but the voltage source. If any DC voltage source is given in the network, you must short circuit directly. Wherever DC source is given, directly you can short circuit out. And the first condition is very important. If you got any capacitors, you think it's so. If you got any capacitors in the network, directly you short circuit. Now initially what you must do, here I got DC sources. Those DC sources must be short circuited because we are applying AC analysis now. That's why I want to write here now. The point I want to write like under, I want to get answer under AC analysis. Under AC analysis, I would like to apply AC analysis here now. Under AC analysis, what you have to do? This circuit I can modify. DC source, AC source must be connected as it is. Whatever the AC source is given, that must be taken as it is. That should not be touched. That must be taken as it is. This is VI. This is AC source. The DC source must be shorted, I said now. Yes, I will short that. I shorted that. The rest of circuit we can draw as it is. There is a MOSFET. That MOSFET I want to draw as it is. That is taken as it is. Here 4 kilo ohm resistor is connected here now. Yes, we can connect 4K. 4 kilo ohm here connected. There I got VDD, DC source. That must be shorted directly now. It must be shorted. That must be shorted now. 2 kilo ohm resistor is connected here now. Yes, I will connect 2 kilo ohm this side. This is also connected to the ground. Here given A, this point is A. This point is A. Yes, I will take VA from here. At this point, I need to get the VA value. VB is required from here. Now, from the B point, we need to get the B. VB is must. In a simple way, I will do. Easily, you can understand. We know very well the current which is passing at the drain. This is the drain. This is nothing but the source. This is nothing but the gate. You know very well. This current, I can give you a name of ID. Drain current, it is going to flow this side. We know very well. The MOSFET can have at the input side very high resistance. Not in mega, it is in giga ohms only positive. Very high resistance now. As we got the high resistance at the gate, what is going to happen? The current, the gate current is to be taken as a what now? Approximately 0 only now. The gate current which is passing this side must be taken approximately 0. Why, sir? Resistance is very high. At the time current is, some current will flow. That current we are neglecting only, we can say. That's why gate current is approximately 0. At the time, drain current and source current will be same. IS and ID will be same only now. Directly I can put it. Now we can find what is VA and what is VB. Just by applying the KVL. Yes, I want to apply KVL in this direction at first. I wish to apply KVL in this direction. If I apply the KVL, I can get VA. I say, when I go this side, 0 voltage equal to, 0 voltage equal to, when I go this side, 4K into ID, 4K into ID plus VA, I'm getting here now, plus VA, I'm getting. The finally thereby required VA value. What is VA? VA is nothing but minus 4K into ID, I can put here now. That is VA. Yes, we are getting this VA. But I want VB also. Just I can apply KVL in this path. Directly I can apply. If I apply the KVL, how I can form an equation? VB equal to, I can write VB equal to 2K into ID, I can get now. 2K into ID, I can get now. Yes, we are getting VA and VB. We are in need of VA by VB, thereby asking to find VA by VB. VA by VB is required. The VA is nothing but minus 4K into ID. 4K into ID. Here, VB is nothing but 2K into ID. 2K into ID. I can cancel ID, KK. Finally, what we are getting here now? Minus 2, I can get here now. The finally value is nothing but minus 2. So I can put VA by VB is minus 2. I can put directly minus 2 only positives now. That is the solution for this question. It's a very simple question now. Try to understand, when a network is given with MOSFET, under AC analysis, is asking to find VA and VB, I calculated. Then ratio, I calculated such a way only now. I think you followed now. I'll go to the next question now. If anybody having any doubts, you can arise their doubts also now. If you got any doubt, you can arise. I'm ready to clarify your doubts. Anybody having doubts regarding this problem? But some students may ask also, they know, sir, I will draw the AC equivalent circuit for the MOSFET also. If you want, you can draw. It's not a problem. Even you have drawn the AC equivalent circuit for the MOSFET, it's going to take some time also. So I want to save the time. If you want to save the time, this is the best way to get answer. Understand? Yes, I will do the next question now. This is one more question. It is also from the ECE branch, GATE 2022. This was asked for 1 mark. Anybody can do this question? But I want to give some time. I want to use some time. Any student can put an effort to give answer. Please respond. You try to give answer for this question. Without my help, you try to give your answer. I'm waiting for your answer. Any student can do this question? Yes, okay, I will do. Please watch otherwise. What is given the problem? An ideal op-amp circuit with a sinusoidal input is shown in the figure. With sinusoidal input, it is given. Vin is nothing but the sinusoidal input. The 3 decibel frequency is the frequency at which the magnitude of the voltage gain decreases by 3 decibel from the maximum value. 3 decibel value is specified. Which of the options is dash or correct? The circuit is a low pass filter, the circuit is a high pass filter, the 3 decibel frequency is 1000 radians per second, the 3 decibel frequency is 1000 by 3 radians per second. Okay, here the, not here one, here the 2 questions are, what now? 2 points you have to remember here now. Is it a low pass filter or high pass filter? We need to identify first. Based upon the given options, we should understand. The given network is a low pass filter or a high pass filter, we need to identify. That means try to identify the type of the filter at first from the given problem. Second one, 3 decibel frequency also required. 3 decibel frequency also very important now, because in the options it is given there also now. That value also calculate now. If it is equal, if any 3 decibel frequency you are getting as it was given in the problem, then we can pick up on it now. Okay, anyhow, I will do this question easily. Can understand the method to do. Initially, I would like to identify the type of filter. What way we can identify the type of the filter? That is more and more important. But our filters will be given with op-amp, you know. They are said to be active filters. Without operational amplifier, filters will be there now. It's a passive filters. Mostly you can find where in the analog only you can find, mostly in the what now? After rectifier circuits, you will see that now passive filters entirely different. But it is not a passive filter. It is a surely, I can say, it is an active filter only. Why, sir? Because we are having the active element of what? Operational amplifier now. So first of all, how to identify the type of filter? You should find the overall gain of the given circuit at first. Overall gain. Overall gain is nothing but V out divided by V in. That ratio is required. Once that ratio you know, once that ratio you calculated, you can identify what is the type of this filter it is. Understand my point now? So how we can find the gain? How we have to find the gain is in a simple way I will explain. This is nothing but the capacitor C1. I can take here now. I wish to take, this is a capacitor C1. This is C1 I want to take. This is R1 I will put now. This is R1, this is C1 value. This I want to take it as a R2 value only. Catch my points. The impedance of this network, you calculate. The impedance at the input side, I got Z1. This impedance I want to denote by symbol Z1. It's a very simple method I'm giving it now. Whatever the impedance it comes in the feedback network, you calculate, that is Z2. Z2 from this feedback network, you calculate. If it is a Z1, this is a Z2, you think it's low. It appears in the form of inverting operational amplifier. If it appears as an inverting operational amplifier, V0 by Vi, the gain is nothing but minus R2 Z2 by Z1, you know formula. For the inverting operational amplifier, the gain is calculated by minus Z2 by Z1. You know very well. The same condition I wish to apply to get the gain. I say, I wish to find initially what is Z1 here. How we can find Z1? You please watch. I wish to find what is Z1. That Z1 and Z2 are required in S domain. That is very important. In S domain only, I want to get here. In S domain means 1 plus, this is an R1 resistor you got now. R1 plus capacitor, whenever you are having, you need to put 1 by C1S. If you got any inductor, you will put LS. L1S you will put now. Capacitor or inductor, any one of that you will find. If you got a resistor, you will put as it is only now. You take LCM for this. If taken LCM, I will get 1 plus R1 C1S by C1S I can get. This is the impedance had by this network, this side input side. Z2, only resistor you got here now, only resistor you got. So I can put Z2 is nothing but R2 only. That is R2 only. Z2 equal to R2 only now. I can put like this, Z2 is nothing but R2 only we got. But I'm in need of gain, V0 by Vi. That is the gain. I can take this as a G also, no problem. G equal to V0 by Vi. It can act just like a what? Inverting operational amplifier. If it is acting as an inverting operational amplifier, I gave you in the class that formula. Not only class, even in the what now? In the the inverting operational can have the gain of minus Z2 by Z1. The student who attended my class, they know better now. The gain of inverting operational amplifier is minus Z2 by Z1. Anyhow, you can take it now. G equal to minus Z2 by Z1 only now. Z2 is nothing but R. This I can put now. Z2 by Z1. Z2 is nothing but R2 here. Z1 is nothing but 1 plus R1 C1S by C1S I can write. Such a way gain is to be taken now. Now the values we can substitute now. The values we can substitute here now. If you want otherwise, what okay, values we can substitute here now. What are the values are given? R2 equal to 2K. R2 equal to 2K and C1 is nothing but C1S, it goes to reverse. C1 is nothing but 1 micro. 1 micro into S divided by 1 plus R1 C1. 1 plus R1 is nothing but 1K into C1 is nothing but C1 is nothing but 1 micro into S we can get here now. Into S we are getting now. Into S we got. And clearly I can write G is nothing but 10 power minus 2 into 10 power minus 3 I can get into S by 1 plus, this becomes a 10 power minus 3 yes I can get here now. 10 power minus 3 into yes. Now catch my point. What is the way gain we got? Now how to find out, how to identify the type of the filter. To identify the type of the filter, you must put initially, put S equal to 0, you put it in the gain. S equal to 0 means S equal to j omega, you know very well. Omega equal to 2 pi times of frequency. So frequency equal to 0, we are using. S equal to 0 means frequency also 0, you know. So when S equal to 0, what gain I can get from this? If S is 0, 0 into something 0, 0 by something is a 0, you know. I can put 0 value. I got 0. This is 0. Next, you put, to identify the type of filter for any problem, gain is must. Next, initially you put S equal to 0, then you find the gain. After that, again you put S equal to infinity. S equal to infinity is a must. S equal to infinity means infinity by infinity you are going to get now. There is no value. Indeterminate only now. In that case, slight change we can have in the question now. Divide in the numerator and denominator by S. In before substituting S equal to infinity here now. If I divided by S, what I can get? 2 into 10 power minus 3 divided by 1 by S plus 10 power minus 3 only possible. That much value. This by S, S cancelled now. 1 by S, S by S means 1 is possible now. Sir, why you divided? Why I divided means when S equal to infinity, 1 by infinity, 0 value, this value. Even this value became 0, some number you are going to get only here now. S equal to infinity, this is 0. What I can get here now? 2 into 10 power minus 3 by 10 power minus 3. I'm getting 2. I'm getting 2, not here now, sorry. Here we can do it now. I will put it here now. In this formula, I can write here now. This value we can write. Anyhow, we got this now. Put S equal to infinity here. I want to get the gain. 2 into 10 power 3, 10 power 3 cancel now. Finally, we are getting 0, 2 only now. The 2 is nothing but non-zero value. It's not a 0, non-zero value. That point is very, very important now. Non-zero value, we know very well. Non-zero value. Now catch my point. Non-zero value of G you are getting at a higher value of S or at lower value of S, you identify it. Catch my point. Non-zero value of G we are getting at S equal to higher value, at S equal to lower value we are getting higher value. If I got G value non-zero at higher value, directly you can put it is a high pass filter. Suppose non-zero value if you got at lower value of S, directly you can say it is a low pass filter. Here directly I can write now, the given circuit is, the given network is high pass filter I can write now. This is high pass filter. This is high pass filter. Yes, we identified it is a high pass filter. So option B is correct here now. Option B is correct because the circuit is a high pass filter. Now I cannot close this question with the work of this, and still it is required 3 decibel frequency also. Is it a MCQ or MSQ? We can see here now. The next what I wish to do, the 3 decibel frequency also I want to find. At 3 decibel frequency, omega value required. That is omega is nothing but 1 by, they will use R1 into C1 only. 3 decibel frequency, 3 decibel frequency in radians per second is calculated by 1 by R1 into C1 only now. The R1 and C1 just to substitute here now. R1 is nothing but 1K means 10 power 3. C1 is nothing but, we got 1 micro, 10 power minus 6. The finally it becomes 1000. It becomes 1001. 3 decibel frequency we are getting 1000 radians per second. 1000 radians per second. Yes, the 3 decibel frequency is 1000 radians per second also given in the given option. So 3 decibel frequency is 1000 radians per second now. So it is a MSQ question. Solution is B and C only now. So finally solution is B and C. B and C only possible. Such a way we need to tackle this question. I hope you followed. Any student having any doubt regarding this problem? If there is any problem, directly you can ask. You can message. Can you message? Anybody having any doubt regarding this problem solution? Yes, nobody is responding. Yes, I will give the next question. One more. I want to give one more question in your hand. This is one more question from the same analog but electrical branch. The question from the electrical branch. This is not complicated question. GATE 2022 problem only now. Anybody can do this question? Anybody can give which option is right? Anybody can give which answer is correct? Which option is correct? I hope easily you can do this question. You take some time and give answer directly. Anybody can give? You think better and give answer properly. If you don't get answer perfectly, I will give no problem now. Yes, I will do now. Please watch. How I am going to do this question, you please watch. First of all, we can see what is asking in the problem. For the circuit shown below with ideal diodes, the output will be, four options are given. Output voltage is given, and also Vn is a greater than 0 or less than 0 or something is given here. Which option is correct is asking. The first of all, in the given problem, you need to identify diodes are ideal or non-ideal. In the problem, you check it. Yes, for the circuit shown below with ideal diodes, strictly given. Ideal diode indicates there is no drop across the diode if it is forward bias. If the diodes are forward bias, directly you can short circuit. It doesn't have any drop for ideal case. If it is a non-ideal, it is given, you think it's so. You must take the drop across diode is 0.7 volts for silicon and 0.3 volts for germanium. That is a must. When they are forward bias only. That's very important. But in case, for ideal case or non-ideal, no problem. The diodes are reverse bias. If diode is a reverse bias, you think it's so. What we have to do? In that case, the diode can act as a what? Open circuit only. Why? Yes, one student. RAM, sound. What sound means? Is it audible or not audible? Sir Ram? Is it audible or not audible? Is it audible or not audible? Please tell me. Is it audible or not audible? Mr. Ram, can you respond? We give this sound. Sound means is it required? Not audible or audible here now? We can set right. That's why. If you responded properly, I can understand. Yes, in this case, the diodes are forward bias or reverse bias here now, we can check now. Suppose what now here it is given, the output will be, what output here required now? Vin is given in case if Vin is greater than 0 voltage, I maintain. If Vin is maintained greater than 0 voltage, if it is greater than 0 voltage, both diodes are forward bias. Because this is nothing but the p-type material, the line indicates n-type material only now. If you are giving the greater than 0 voltage, P is connected to the positive electrode, positive supply only now. Positive electrode or positive supply only now. At the time, this diode is forward bias. But in this case, in the second case here now, this diode what are now? Same positive is connected to positive this side. Negative is connected to the negative only this now. This side negative is connected. I will write clearly. This is negative here. If you are giving the if Vn is a greater than 0 voltage, both diodes are on state only now, because both are forward bias only now. Input is the sinusoidal waveform only now. I am giving the positive pulse initial. At the time Vn is greater than 0 voltage, D1 is on here, and D2 also on. Both diodes are on here now. Both diodes are on. I can say here now. If both diodes are on, they must be replaced by short circuit. Both diodes must be replaced by short circuit because they are forward bias only now. I can draw diagram like this now. This is short circuited, resistance R, here connected with VI. VI is nothing but the positive. And I want to get V naught. What V naught I can get? Anybody can respond? If both diodes are forward bias, they are replaced by short circuit here now. Those two are replaced by short circuit. Resistance R is connected here now. But can you say what V naught I can get from the given network? what V naught I can get from the given network. V naught equal to VA only now. I will get V naught equal to VI. I'm getting V naught equal to VA only now. The same, this voltage, same only. If VI is less than 0 voltage, less than 0 voltage means this value only now. Negative pulse we are giving now. When the input voltage is given negative potential, at the time both diodes will be reverse bias, because P type is connected to the negative pulse, negative. At the time D1 and D2 comes to off state only now. When diodes are reverse bias, they must be replaced by open circuit only now. What I say is, if VI or Vin is less than 0 voltage, D1 is off and D2 also off. Both are off. Both are off only positive. If both are off, what is going to happen? What V out? V naught or V out are both are same now. What is available here now? V in is a less than 0. VI is a less than 0 means I can draw circuit like this now. The diode is reverse biased. The resistance is connected here. The diode is a reverse biased. I am giving here now. What pulse? Negative pulse only given. This is a VI. This is a negative pulse only given here now. This is R. What V naught I can get? If the both diodes are reverse bias, it doesn't flow any current across resistance R. No current will pass across resistance R. If there is no current drop across, this R is to be taken as a 0 only now. I can put directly V naught equal to 0 voltage. So finally, which option is correct? If Vin is greater than 0 voltage, the Vin is greater than 0 voltage, V out equal to Vin. Option A is correct. Vin is greater than 0 voltage, V out equal to Vin only now. The remaining are not satisfying. Vin is a less than 0, V out equal to Vn. It's not correct. The Vin is greater than 0, V out equal to minus Vn. Impossible. Vin is a less than 0, V out equal to minus Vn. That also not possible. Finally here, option A is correct in this particular problem. I hope you follow. Next question. This is the next question. Anybody can do? I will give some time. Please try this question. You take some time and try this question. Anybody can do this question without my help? But I will see how many students can give. This is a very simple question. Any student? Any student can give answer for this question. Yes, I will explain, please watch. But it is also GATE 2022 analog problem. This question was asked in electrical branch. For an ideal MOSFET biased in saturation, the MOSFET is in saturation is given. It is biased in saturation. The magnitude of the small signal current gain for a common drain amplifier is asking. That is very, very important. A common drain amplifier. 4 options are given. Current gain we want. But small signal current gain, voltage gain, input impedance and output impedance we can get from the amplifier only under AC analysis. There is a small signal analysis only now. But anyhow, thereby required current gain. We should know one point clearly now. For common drain amplifier, it is given common drain amplifier. For common drain amplifier, For common drain amplifier in the MOSFET AC analysis, if you watch, you can understand clearly. For common drain amplifier, current gain AI is calculated by the source current divided by gate current. That ratio is to be taken as a current gain only now. Source current divided by the gate current. That ratio is to be taken as a current gain only now for common drain amplifier. But you know very well, the gate can have, the gate side you can have the high resistance in the MOSFET, very high resistance, I said already. Because the high resistance gate current is approximately equal to what I said already, zero value only now. That's why what I wish to say, the gate current is approximately equal to 0 amperes only possible, because of the high resistance existing at the gate only now. Because of the SiO2 layer you are going to coat, the coating is made. Because of that we can have the high resistance only, you can say. So finally current gain equal to how much it is possible here? IS by 0. Something by 0 is nothing but infinite. Infinite is possible. So which option is correct here now? Option D is correct here now. It's a very simple question. Infinite only possible. As gate current is approximately 0, current gain equal to infinite is possible. That is the solution for this question. I think you followed. This is the answer for this question. Next one. This is the next problem. Anybody can do this question? I want to give in your hand. I wish to give this question in the hands of you. You please try this. It's not a 0 point, sorry, it's given 0 only, sorry. 0 voltage only, this one. This is 0 voltage. This voltage at 0 voltage, same 0, because ideal they are. Ideal op amp and ideal diodes only get almost 0 voltage. At 0 voltage, 0 current only. Anybody can do this question? Anybody can tackle this question without my help. I will wait. Please try to tackle this question and give answer. Your valuable answer is very important. Please respond. Please respond. What answer you are getting? You please tell me. I will check. Options are given here now. These are all the options. 15 voltage, 27 volts, 13 volts, and 14 volts given. You can try this. Anybody? Any chance to give answer? If you are not in a position to do this question, please respond. I'm ready to start. I will do the question. Yes, I will do this problem. You try to understand this now, easily can understand. For the following circuit with an ideal op amp, the difference between the maximum and minimum values of capacitor voltage VC is dash. Here connected one capacitor is asking to find the minimum VC and also maximum VC required. Difference between these two values, that means VC maximum minus VC minimum is asking to find. That difference is more important. VC maximum minus VC minimum is required. The difference is more important. How we can find the difference? How we can find the difference? Here, how we can find this difference means there is an op amp here. This op amp having the positive feedback also here now. Positive feedback also we are having now. if you are having any positive feedback in an operation amplifier, the output must be plus V sat or minus V sat only possible. Only these two, any one of the value is possible here now. I made an assumption. Initially, this output voltage is nothing but plus V sat I want to put here now. Sir, why that V sat value is required here, sir? Very good. That point is very important now. I wish to find this V naught value. Once I got this V naught, I can determine V plus value. V plus I can determine. V plus is nothing but voltage across these resistors only now. Whatever the resistance you will get, voltage across those resistances only now. Anyhow, V plus you find. V plus and V minus are same because it is an ideal op-amp directly given. In ideal op-amp, V plus and V minus are same. V plus once you got means same V plus. The V plus is nothing but voltage across the capacitor only. The voltage across the capacitor is nothing but that voltage only. But then I can get maximum because we are putting V naught equal to plus V sat. In that case, I may get V maximum, VC maximum I can get now. In the next level, what you have to do, V naught equal to minus V sat, you take it now. V naught equal to minus V sat. You find what is V plus. That V plus equal to V minus. The V minus is V minus. V minus is nothing but the voltage across the capacitor. That potential will be taken as a what? Minimum value of this capacitor voltage. Then you can find difference between these two. You know. How we can find these values, the difference you ask, I will do now. You can understand here. Initially, I made an assumption. V naught equal to V sat. V sat is nothing but the 15 voltage. I selected V naught equal to 15 voltage. V sat. If it is 15 voltage, at this point, if I got a 15 voltage, how those diodes will be biased? Check it. This diode is opposite to the what now? This potential now. This is the reverse bias. In the first case, this is reverse bias initially. Then this diode is a forward bias only here now. This is forward biased. This is 0 voltage means 0 current now. This is a forward bias. If the diode is forward bias, it must be replaced by short circuit, you know very well. The diode is reverse bias, it must be open circuited, we know very well. So I can draw the diagram at first, like this only now. There is an op-amp. There is an op-amp. Here I want to take V naught equal to 15 voltage. This is a 15 voltage I have taken here now. This is 15 voltage. And this side, voltage across the capacitor is required. This voltage I want. There is a resistor. That resistor is not required. Value is not required. There is some resistance is there now. This diode is a reverse bias. If it is reverse bias, this is open circuited now. R and R I can have. R plus R, 2R I will get. 2R directly. Because this is open circuited now. This branch is removed. R plus R, these two are in series. 2R I can get here now. This D1 is forward bias. Catch my point. The diode D1 is forward bias. This is short circuited. If it is short circuited now, no current is going to pass across this R. At the time, even if you remove that R, it doesn't problem. It doesn't have any problem now. The diode is shorted and connected to the resistance R directly here now. I say, I'm repeating here now. I say, this can be drawn in this way. This is shorted. The resistance is not going to have any importance now. That is unnecessary. It doesn't have any importance now. This is shorted here now. Here I connected with resistance R. This is connected to the ground. Such a way this network is formed. Such a way network is formed here now. But I want voltage across this capacitor. This is a minus, this is a plus, you know, V minus. This is nothing but V plus. But I wish to find what is V plus. V plus is nothing but because the resistance is not having any importance now. The circuit path will be taken this side only. Only this side only positive. But this V plus is nothing but voltage across this R. Only this R. This R doesn't have 0 into, because if you simplify 0 into R by 0 plus R, only short circuit only total. I can say V plus is nothing but voltage across this R. Supply voltage, voltage divider formula, I can apply V naught into R by R plus 2R, 3R I can write here now directly. 3R I can write. So RR cancel, 3 5s, 5 voltage I am getting. I am getting 5 voltage. Because when the 15 voltage is given, current will pass this side, the current will pass this side, the current will pass this side, the current will pass this side. It doesn't flow any current across this terminal. Why it doesn't flow current through this side? Ideal op-amp can have very high resistance. Input resistance is infinity only now. When the infinite resistance had by the operational amplifier, the current is approximately 0 this side. The current is 0. There's whatever the current is passing this side, same current will pass in this direction only, I can say. That point is very important. Anyhow, we got V plus is nothing but 5 voltage. What about V plus and V minus are equal here now? V minus equal to what? V plus equal to what? Same 5 voltage. The same V minus voltage across the capacitor. So finally VC is nothing but VC maximum it is. VC maximum equal to 5 voltage. Yes, I've calculated VC maximum. But you please try what is VC minimum you calculate. I will use some time. You please try this. You please try for VC minimum. What VC minimum you can get from the given accord. You please try and tell me. I will check the answer. I will check the value. Are you going to get the value perfectly or not? I will check. Anybody? Anybody can get? Anybody can give? The second case I'm asking here now. When V naught equal to V sat, I determine VC maximum now. When V naught equal to minus V sat, you calculate VC value. Then we can determine the difference of the voltage. Otherwise, I will take, please draw. I will draw, please watch it now. I will do this now. But I want to draw when if, I'll draw. If V naught equal to minus V sat, I have taken here now. What minus V sat is given in the problem, you please check it. What minus V sat is given? Minus 12 voltage is given. Plus V sat 15, so minus 12 voltage is given. Minus 12 voltage is given. Minus V sat minus 12 voltage. But I would like to draw the circuit. I would like to draw the circuit here now. How I can draw the circuit, you please watch. There is an op-amp. I will draw the op-amp. Minus N plus. This side I want to get the V naught. There is one resistor. There is one capacitor here. I want to get voltage across. This capacitor is required. Voltage across that capacitor is required. And also what they were all connected here now. This side R and R here given. I'll connect first of all. This side connected with R and R. This is R. This is R. One diode is there now. Next we can discuss the diode. And also here given one resistor R and R here given. This is one of the R and one more R is connected here. These two are connected to this side. And the diodes we can see now. What about the diode? Which diode is on and which diode is off? We can see. When you are giving the negative potential, catch my point. When V naught equal to minus 12 voltage, which diode is on? You watch it now. When the negative potential V naught is taken here now, if taken V naught equal to minus 12 voltage, if it is connected here, this is forward bias. This diode is a forward bias. If it is forward bias, it must be shorted only now. It must be shorted now. This diode is reverse bias. This diode is reverse bias. If this diode is a reverse bias, it must be open circuited only now. I say this diode is forward bias. If it is forward bias, I can connect like this. I can connect like this only now. I can connect directly. This is shorted only now. Forward bias only now. The next one, this is forward bias, shorted only here now. This side it is a reverse bias, it is a open circuited only now. This is open circuited here now. This side it is open circuited. This is open circuited. This is open circuited. Such a way we are getting the circuit, final circuit we got such a way only. Now thereby required this voltage across this capacitor is required. How we can find voltage across this capacitor? Initially you find what is V plus equal to V minus equal to voltage across the capacitor only now. But how to find this V plus, that is very important now. V naught equal to minus 12, you know very well. I want V plus, this is V plus. If it is open circuited, total resistance is nothing but the 2R. If it is short circuited now, the resistance will not have any effect. The current will pass in this direction and will go this side and will pass this side and will go this side only. This is the direction. It's possible now. That's why V plus is nothing but voltage across this 2R minus V sat according to voltage divider formula. Minus 12 into 2R divided by 2R plus this R. 3R is possible here now. So I can cancel this R and R, I can cancel, R and R cancel, 3, 4 times it is cancelled. Finally, I am going to get minus 8 voltage here now. So I am getting V plus equal to minus 8 voltage. In the problem strictly given here now, it is an ideal op amp. If it is an ideal op amp, V plus and V minus are same. So V minus equal to, I can put V plus, that equal to what voltage? Minus 8 voltage I can say. This voltage can also be called as a VC only now. V minus equal to voltage across this capacitor only now. Voltage across this capacitor, both are same only now. Finally, we are getting, this is a minimum value I am getting here now. This is minimum. But in the problem you check it, what is asking to find? The difference between maximum and minimum voltage is required. Maximum minus minimum. Maximum is 5 volts. Maximum, VC maximum minus VC minimum is asking. VC maximum, what we are getting now? VC maximum is 5 volts, we know very well. This is with 5 voltage. VC minimum is nothing but minus 8 voltage we are getting here now. 8 plus 13 voltage is possible. Finally, difference of that voltage equal to 13 voltage is possible. That is the solution for this question. I think you followed. Any students are having any doubts regarding this problem? If you got any doubt, please ask me. I am ready to clarify your doubts. Any student having any doubts? Yes, one problem I wish to give in your hand only now. You try. If you are getting answer, very good. If you don't get answer, in the next class, I will do that question right now. I will do that question now. But you please try to respond, understand now. But try to give answer now. Now I will give, otherwise now you try to tackle this question. You try to do this question. Yes. You please try this question and give answer. Please try to give answer for this question. This is one of the gate problem. This is from the ECE. This again is 0.7 is given now. Voltage across the diode 0.7. Ideal or non-ideal? It is a non-ideal diode. Directly given. Diode is non-ideal. At 0.7 current is going to increase across the diode is given in the characteristic curve. So it is a non-ideal diode. But he is asking to find dou of V out by dou of V in. What the ratio of minimum to the maximum small signal voltage gain, dou of V out by dou of V in is asking now. Anybody can do this question? It's a very good question, I think. Today you try. You practice. If you are not getting the proper answer, you think it's so, in the next class, I will do. You get the full clarity. Okay then. Thank you.